So, good morning, everyone. We are Group One, and I will be presenting the electronics assembly presented by our group: Agustin Brian Mayaspi, Alvarez Jerome C, Capistrano Tony Rose, Degi Tronica Grace, Ginto Edmonds, and Malto Carlo, and Rivera Harold, and Sir John Vincent. I will be the one presenting, and my name is Malto Carlo. Once again, good morning to all. So we will start the presentation with the actual PCBA process, or the printed circuit board. Um, so for the step one, solder paste stenciling. To assemble a PCB, assemblers apply solder paste to certain parts of the board. These parts are where components will sit in the would-be PCB. So the solder paste composition po natin is contains 3% silver, 5% copper, and 96.5% tin. The solder paste itself is a gray substance consisting of tiny balls of metal, also known as solder. Solder paste makes a solder with the flux, which is a chemical designed to help the solder melt and bond to a surface. It must be applied to the board exactly at the right places in the precisely right amounts. Step 2. Next slide, please. Next is the pick and place. So dito naman po, ang gagawin po nila is yung pagdalagay ng surface mount technology. So after applying solder paste, a robotic device places surface mount components, or SMDs, on a prepared PCB. SMDs account for most non-connector components on PCBs today. The robot picks up a PCB board with a vacuum grip and moves it to the pick and place station. Components are placed on top of the soldering paste in pre-programmed locations. The robot then applies the SMTs to the surface of the PCB using a soldering tool. As you can see, meron po kami ditong picture na kung saan yung...
May picture ka ba dyan o mga video ganon, may mga illustrations?
Ito po yung picture, yung nasa taas po. Tapos, after this process, we'll be presenting a short video po for the process. Okay. So, as you can see, meron po ditong pad and then yung solder which connects po yung component na pre-program, and yung LED po, then yung pinaka-PCB, yung green layer natin. So, yung distances po ng pad natin and yung iba't ibang components is pre-programmed in order to ensure na yung ating PCB ay gumagana effectively. Step 3. Next is yung reflow soldering. So solder paste and surface mount components are all placed on a PCB at a temperature of 400 between 250 degrees Celsius or 480 degrees Fahrenheit. Thus, this means that the solder paste needs to solidify adhering components to the board. The process known as reflow accomplishes this through a process called reaction assembly or circuit board assembly. So, after the pick-up and place process, the PCB board is transferred to a conveyor belt which moves through a large reflow oven. This oven consists of a series of heaters which gradually heat the board to temperatures around 250 degrees Celsius or 480 degrees Fahrenheit. The heat is hot enough to melt the solder in the solder paste. Once the solder melts, it passes through a series of cooler heaters to allow it to cool and solidify in a controlled manner. This creates a permanent solder joint that allows the SMD to be connected to the board. Next step. So next is this inspection and quality control. So after making the PCB, nandun na po tayo sa quality checking. So often, movement during the reflow process will result in a poor connection quality. Shorts are also a common side effect of this movement, as misplaced components can sometimes connect parts of the circuit that should not be connected. So yung inspection po natin and quality control measures includes manual checks, automatic optical inspection, and X-ray inspections. Next step. So, ito po yung checking for these errors and misalignments can involve one of the several different inspections. Ito po lang, common inspection methods, as I've said earlier. Next po. Step 5, through-hole component insertion. Depending on the type of PCB, the board may have a number of components in addition to the standard SMDs. These include plated through-hole components or PTH components, as well as ones with no holes in them. A plated through hole is a hole in the PCB that's plated all the way through. Soldering paste won't do any good as the paste will run straight through the hole. Next. PTH components requires a more specialized type of soldering procedure in the later PCB assembly process rather than soldering paste. So kapag po yung ginagamit po natin na PTH component naman ay gagawin po nila manual soldering, then next is wave soldering. So after this soldering procedure is completed, the PCB can proceed to final inspection or it can return to the previous step if additional parts or another side of the PCB are required. Next. So step 6, the final inspection and functional test. So after the whole process of soldering and the PCB assembly, the PCB will be inspected for functionality. A functional test puts the PCB through its paces by imitating the usual operating conditions. In this test, testers examine the electrical characteristics of the PCB as power and simulated signals are sent across it. If any of these characteristics show unacceptable fluctuations or heat peaks, the PCB fails and the test can be recycled or scrapped. Testing is the final and most crucial phase in the PCB assembly process since it indicates if the process is successful or not. This is also why it's critical to perform regular testing and inspections during the assembling process. So here is an example of a flow diagram of how the manufacturing process of PCB happens. So sa A side po natin, solder pasting ng printing, then attachment of SMD, then reflow soldering, then flip to attach another other components to the other side or the B side. So next po is solder paste printing, then adding of SMD, then heat curing, and then flipping again. Tapos pagdadagdag po ng through hole, then wave soldering, tapos washing, and finally inspection. Next po. Pa-play po nung ano po natin, video po.
Video ba yan?
Yes po, na mismo ang PCB.
Okay, very good. Sige, kahit galing sa YouTube, walang problema. Pero pag nilagay natin sa channel, hindi natin malalagay kasi bawal, di ba? Pero kung ano, yung papanoorin lang, okay. Pero pag nilipat ko sa channel ko, hindi pwede. Kasi may sariling ano yan, copyright. Ha? Ilan, pwede mong share kung galing sa YouTube. Paki-full presentation mo para hindi kasama yung gilid. Yan. May sound ba yan, sir?
In this video, we'll be exploring a critical segment of the electronics industry known as electronics assembly. Electronic products consist of components and interconnections. Components are devices that alter the flow of electricity, such as resistors, capacitors, and semiconductor chips. The interconnections are the pathways where the electrons flow between the components. The driving force of most electronic products is the circuit board assembly that interconnects all of the electronic components. There are two basic categories of electronic components: through-hole and surface mount. Through-hole components contain leads that are inserted into holes in the board. One example is a dual inline package, or DIP. Through-hole components like resistors and capacitors come in axial or radial leaded packages. These types of components have been around a long time. Surface mount technology is much newer and has become the dominant technology, mostly because the components are smaller, which satisfies the increasing need for miniaturization. The leads or terminations of surface mount components are placed directly onto lands on the surface of the circuit board. This integrated circuit resides in a quad flat pack, or QFP, with gull wing leads. There are also components with J leads, such as plastic leaded chip carriers or PLCCs. Some of the more modern surface mount components include ball grid arrays or BGAs, chip scale packages or CSPs, and bottom termination components or BTCs. Surface mount resistors and capacitors are called chip components. Chip components have terminations instead of leads. Now that you have an understanding of the different categories of electronic components, let's go on a guided tour of the processes used to manufacture and verify circuit board assemblies. We'll start with surface mount.
We will be proceeding po I think sa semiconductor, another electronic component that can be found on PCB's assembly. First and foremost, what is a semiconductor? A semiconductor is a silicon-based material that conducts electricity better than an insulator like glass, but not as well as a pure conductor like copper or aluminum. The inclusion of impurities known as doping can change their conductivity and other properties to match the unique needs of electronic components in which they live. Next slide. So, ito po yung short table of contents po namin. So, we'll be starting with the history, classifications, then properties, applications, and lastly, the types of semiconductor devices. So for the history. First known, I think, semiconductor is recorded in 1904. Two-electrode vacuum tube is invented. So Thomas Alva Edison, the inventor of the first practical incandescent light bulb, had also noticed that the direct electric current flowed from a heated metal filament in the bulb to the other electrode only when the latter had a positive voltage. John Ambrose Fleming used this effect, known as the Edison effect, to invent the two-electrode vacuum tube rectifier. So in 1946, world's first general-purpose computer, ENIAC, is announced. ENIAC was the largest electronic machine ever made, equipped with some 18,000 vacuum tubes and weighing about 30 tons. It occupied a 160 square meter room. The computer consisted of a total of about 110,000 electronic circuit devices. Next, on about 1948, a junction-type transistor is invented. Toward the end of 1947, John Bardeen and Walter Brattain at AT&T Bell Labs developed the point contact transistor, which was the first transistor ever constructed. William Shockley and his team continued with this research and announced the invention of the mechanical solid junction type transistor in June 1948. Next. So in 1955 naman po, Japan's first transistor radio is released. So early broadcast radio receivers used vacuum tubes. So by replacing vacuum tubes with semiconductor transistor devices, radios became smaller, lighter, and less power consuming. In Tokyo, the company of Tokyo Chushin Kogyo, Tokyo Telecommunications Engineering Corporations, are now known as Sony, released Japan's first transistor radio, which is called TR-55 in 1955. Next, in the 1957, Esaki diode is invented. Ryo Esaki made an artificial structure consisting of two layers of different semiconductor materials separated by a thin electric layer of 10 nanometer or less, and discovered that the electron tunneling effect occurs within this structure. So habang tumatagal po, lumiliit yung semiconductor natin at mas nagiging proficient yung application niya sa iba't ibang devices. So in 1959, Kilby patent is filed. So the Kilby patent refers to the patent on the basic concept of integrated circuit developed by Jack St. Kilby at Texas Instruments. Next. On 1965, Moore's Law is announced. In 1965, Gordon Moore, who later became a co-founder of Intel, predicted that the integration rate of LSIS would double every 18 months, implying that it would quadruple in 3 years and become 1,000-fold denser in 15 years. The prediction, known as Moore's Law, was based on the analysis of historical trends in the computer manufacturing industry. Also, on 1971, Intel 4004 is released. Intel's Ted Hoff proposed the idea of universal logic processor, which was taken up by the Masatoshi Shima at Busicom and Federico Fagin at Intel, who completed the chip design. So 1977, invented po yung world's first personal computer, which is Apple II. Many consider the Altair 8800 to be the world's first personal computer. Its manufacturer called it a mini computer, along with other designations such as microcomputer and home computer. In contrast, Apple's Steve Jobs used the term personal computer, which took the whole with the commercial success of Apple II. Next po is noong 1980, flash memory is invented. Flash memory is a rewritable semiconductor memory device that is non-volatile, meaning it retains the information when power is turned off. Flash memory was invented in 1988 by Fujio Masuoka, then a Toshiba employee. Next is 1983, Family Computer is released. In 1983, Nintendo released a video game console fitted with an 8-bit CPU. The Family Computer Famicom became a smash hit on the back of the popularity of Super Mario Bros., a game developed by Nintendo as well. Encouraged by Famicom's success, the company released a 16-bit game console known as Super Famicom in 1990. Next po is in 1991 is yung further ng carbon nanotube. So, the discovery of carbon nanotube by Sumio Iijima in 1991 was a pivotal event in this field. Carbon nanotubes have many excellent properties that includes over 1,000 times greater electric current density and 10 times better room temperature thermal conductivity than copper. So, next po, 1993, first practical blue LED developed. So, light-emitting diodes, otherwise known as LEDs, have been considered ideal for making display panels. The application required three primary colors, namely red, green, and blue. However, there had been no practical technology to manufacture blue LED until 1993 when Nichia Corporation and Shuji Nakamura developed the blue LED technology. Their achievement made full-color LED displays possible. Next po, further or pag-improve naman ng TV displays. So, Sharp releases liquid crystal display or window. Epson went on a release of a packet-colored TV with a 1.2-inch transmissive TFT LCD in 1984. No LCD TV with a reasonably large screen was available until 1995 when Sharp introduced a 10.4-inch TFT model as a part of the Windows series. Next po, in 2002, Earth Simulator records world's fastest processing speed of 35.86 TFLOPS. Designed to study global climate change and the mechanism of strata shifting and diastrophism, the Earth Simulator set the world record performance of 35.86, running the LINPACK benchmark in June 2002. So, ito po, Earth Simulator is a kind of parang supercomputer. Ang purpose mostly is to monitor climate change nga po, tapos weather conditions. Next po. In 2004, graphene creation experiments proved successful. So, Andrei Kim and Konstantin Novoselov applied clear adhesive tape to a block of graphite, leaving a thin layer of graphene. Graphene is expected to enable highly efficient solar cells, very sensitive touch panels, and many other useful applications. Next. So 2007, Apple announces the iPhone. The announcement of iPhone by Steve Jobs on January 9, 2007 completely changed the landscape of the global mobile phone industry. The iPhone was designed to use what he called the best pointing device in the world, our fingers. Next po, pag-release ng Apple ng iPod. So, Steve Jobs introduced Apple's fourth innovation after Macintosh, iPod, and iPhone on January 27, 2010, the iPod. According to him, was a multi-touch information device that would straddle between laptops and smartphones. So, kumbaga po, ginawa po niyang idea is to make parang convergence ng malaking screen ng laptop and yung portability niya, pati yung pagkakaroon po ng large space for files and applications, tapos yung pagiging touchscreen ng smartphones. Next. On November 2011, K-Computer achieves world's fastest processing speed of 10 petaflops. The K-Computer, Japan's next-generation supercomputer that has been developed under the guidance of the Ministry of Education, Culture, Sports, and Science and Technology, recorded the performance, running the Impact benchmark in June 2011. Next po. 2013, Google Glass beta test starts naman po. So, ngayon naman po nauso yun, noong 2013 ng virtual reality and augmented reality na technologies. So they are computer-generated environments perceptible to humans just as they perceive real-world information. So VR is for sight, and then augmented naman po overlays computer-generated images on real-world scenes. Real-world scenes to extend or
ano yung AR natin? Ano yung AR? Ano ibig sabihin ng AR?
Augmented reality po.
Augmented. Sige.
Kumbaga po, wait lang po. So, yung sa VR po, purely artificial po siya. Kumbaga, merong, pag kinumpare po kasi siya, merong parang pixelated po yung sa VR. Kumbaga, start from scratch po siya. Yung programmer po or yung designer po ng application, siya po yung magde-design nung pinaka-world na gagawin niya. However, yung AR naman po, yung real-world images po, for example, meron po siyang scenery na ginawa. Ang example po, nasa Bariswain Church po siya, for example. Tapos, ipipaste po niya dun sa application niya. Tapos, once na ginamit po ni user, yun po yung makikita niya. Ganun po. Yun po yung pinagkaiba nila. Next po. So, on 2015 naman po, Ken Sakamura receives ITU 150 award. So, computer scientist Ken Sakamura, one of the pioneers in the field, dubbed this concept ubiquitous computing, putting forward an open computer system architecture known as Theron. It was much later, around 2014, that the concept came to be popular known as the Internet of Things. Next po. AlphaGo defeats a human Go master. So, next one po is in development ng artificial intelligence. Artificial intelligence was first established as a research discipline at a conference in Dartmouth College in 1956. However, with the introduction of commercial databases in the 1980s, investment in AI research began to gain momentum. In 2016, the AlphaGo AI program developed by DeepMind defeated the human world champion in the game of Go. Familiar, siguro, paano ko explain? Para pong checkers yung Go game. So, kumbaga strategy-based game po siya. Next po. Next is yung classification of semiconductors naman. So, we have intrinsic semiconductors and extrinsic semiconductors. So, for the intrinsic semiconductors, an intrinsic kind of semiconductor material that is chemically extremely pure. As a result, it has a low conductivity level and a small numbers of charge carriers, mainly holes and electrons, which it has in equal amounts. Makikita po nyo dito yung bonding ng free electron hole, tsaka ng hole po niya, pati po ng ating silicon. As you can see po dito. Next po, extrinsic semiconductors naman po. They are the ones that seem to have minimal quantity of impurity introduced to the intrinsic material. This doping involves using an element from a different periodic table group, which has either more or less electrons in the valence bond than the semiconductor. This results in either an abundance of or a deficiency of electrons. So dito naman po, nag-introduce naman po ng yun nga po, element from a different periodic table. Kung kuwari po itong plumbum or lead, then yung boron po, na ibabond po nila sa silicon for an example. Tapos yung sa lead po or plumbum, meron po siyang excess na electron. Tapos yung sa ano naman po, sa isa naman po, which is yung P-type na ang tawag, kulang naman po siya ng electron. So, nag-accept po siya ng impurity, creating a hole. Tapos yung sa plumbum naman po, N-type naman po yung tawag po sa kanya. Next po. So, P-type semiconductors. P-type is made when a small amount of a trivalent impurity is added to a pure semiconductor, resulting in the information of a large number of holes. The addition of trivalent impurities such as gallium and indium to the semiconductor material results in a large number of holes. Ito po yung example niya. Next po, N-type. Ay. Next po, N-type semiconductor. A form of extrinsic semiconductor that contains 5 electrons in its valence shell and is doped with the pentavalent impurity element. To enhance the amount of electrons available for the conduction, pentavalent impurities or dopant elements are added to N-type semiconductors. Next po. Next po is some properties of semiconductors. So, first po, a semiconductor acts like an insulator at 0 Kelvin. On increasing the temperature, it works as a conductor. Semiconductor can be modified by doping to make semiconductor devices suitable for energy conversion switches and amplifiers. Number 3, lesser power losses. Number 4, semiconductors are smaller in size and possess less weight. Number 5, their resistivity is higher than conductors but lesser than insulators. Number 6, the resistance of semiconductor materials decreases with the increasing temperature and vice versa. So, all in all, ang semiconductor po natin can be categorized na something in between a conductor and a simulator na you can have, kumbaga katulad po rin sa first na property, pwede po tayo mag-set ng nakadepende po yung performance niya base sa temperature na ina-apply sa kanya. Next po. Applications of semiconductor. Iba't ibang appliances po na pwede po siyang gamitin. And next. Yan. So, sa types of semiconductor devices, ito po ay isang operational amplifier o op-amp, is an integrated circuit that amplifies the difference in voltage between two inputs. It is also named because it can be configured to perform arithmetic operations. An op-amp has 5 terminals: positive power supply, a negative power supply or ground, non-inverting input, inverting input, and the output. Next po. Next po is an integrated circuit or IC. It's a small semiconductor-based electronic device consisting of fabricated transistors, resistors, and capacitors. Integrated circuits are the building blocks of most electronic devices and equipment. An integrated circuit is also known as a chip or microchip. Next po, resistors. A resistor is an electrical component that causes resistance in the flow of current. Resistors are used for many purposes, including limiting electric current, voltage division, heat generation, matching and loading circuits, gain control, and setting time constants. Wait lang po. Sorry po, wait lang po. May tao lang po sa labas.
Oh, sige.
Sorry for the convenience. So for the resistor po, as you can see, meron po silang apat na bands na pwede nyo pong i-identify yung value of your resistor. So for the first po, band A, yung first digit, second po yung band B, yung second digit, then multiplier, tapos yung lastly po, yung tolerance niya, which can be either gold or silver. Next po. Types of semiconductor, the capacitor has the ability or capacity to store energy in the form of an electrical charge, producing a potential difference or static voltage across its plates. Next po, is a semiconductor device that may be used to amplify, control, and generate. I guess this is also a form of yung kanina po, and generate electrical signals. The active components of integrated circuits or microchips are transistors, which often have billions of these small devices etched onto their gleaming surfaces. Next po is ang diode, an electrical component that allows the flow of current in only one direction in circuit diagrams. A diode is represented by a triangle with a line across one vertex. Ayan po. So makikita yun. Sige po. So makikita po dito yung one flow lang po siya from a positive to negative charge po siya. Ayun po.
Saan galing yung ano? Pakibalik mo nga doon. Saan galing yung ano, direction ng current yan? Mula sa
mula po sa positively charged to negative. Ay, tama.
tama
Positively
yun.
charged to
Mula
negatively
positive
charged.
papuntang negative, no? Kung saan yung direction ng arrow. Diba?
Yes.
From positive to negative. Hanggang doon lang ba yung report nyo?
Yes po, sir.
Okay, sige. Okay, very good naman. Thank you very much.